Let's go over some review from geometry. Doesn't that sound like the most fun you've ever had? So basically, each page kind of has one overarching topic that you should have learned in geometry last year. Emphasis on should. So the first we have is Pythagorean triples. These are just common ratios that appear that work with the Pythagorean theorem. So the 3, 4, 5 is the one that you have heard the most probably, and the multiples of it work too. So if I took 3, 4, and 5 and multiplied it by 2, I'd get 6, 8, and 10. That works as well. If I multiplied the 3, 4, 5 by 3, that works. I multiply by 10, multiply by anything. As long as I multiply by the same thing, the 3, 4, 5 right triangle is always going to work. Same with 5, 12, 13, 8, 15, 17, and 7, 24, 25. These are just the four ones that appear pretty often, and they're kind of subcategories. So like these are the ones that I am the most familiar with. And if you're familiar with them, then you don't have to do as much work because you can just look at a triangle and just fill in the missing sides based on knowing the pattern, right? Like if I had a 3 and a 4 as legs, I could just immediately say that the hypotenuse was 5 without actually doing any real work to get there. So that's all that is. Don't spend a lot of time memorizing it. It's just something that you want to try to become familiar with, I think. Next, we had solving right triangles. So solving right triangles is when you find all missing sides and all missing angles. Okay, so you would be able to identify technically all three sides and all three angles. All we're going to do is just list the missing one. And you can achieve this in a right triangle if you have two sides. You can find the third side using the Pythagorean theorem, and then we can use inverse trig to find angles. You could also do it if you have, like the example we're going to do, one side and one of the measures of the angles. We can use trig in order to find the missing side lengths, and we can use basic geometry skills to help us find the missing angle. So what I'm going to do is kind of set myself up over here and say I wish that would have written what I asked it to. All right, there we go. Measure of angle K is something I need to find. I need to find side little m, and I need to find side little k. All right, so those are the things that I need to find in order to have fully solved this triangle, because we already know that L is 90, M is 40, and we know that side L is 8. So in order for me to find K, angle K, the easiest way to do that is to say I'm in a right triangle. That means that the two acute angles, so M and K, have to add to 90. So if one of them's 40, then the other one has to just be 50. Okay, so I don't really need to do a lot of work there. You can also do 180 minus 90 minus 40 is going to equal K. It's just in right triangles, we don't need to do the whole 180 minus 90 because that's just always going to be 90. Now, for the rest of this, what I'm going to do is pick trig values that will help me. So if I want to find M, what I'm going to do is use sine. So I'm going to say sine of 40 degrees is going to equal M over 8, and then I'll just multiply 8 to the other side to get that M equals 8 times sine 40, and then I just type that into my calculator, and I get 5.14. So that is how big M is. For K, I'm going to use cosine because K is the adjacent side. So I'll do cosine. Does not like doing O's today for some reason on my computer here. Struggle is real. I'll get K over 8, and then I'll multiply the 8 to the other side. So I'll have K equals 8 times cosine of 40 degrees, and I just type that into my calculator, and I get 6.12-ish. One thing I just want to remind you about from geometry is that side lengths correspond to their angles, meaning that if you have a small angle, you'll have a small side. So 40 is my smallest angle, so it makes sense that M is going to be the smallest side at 5. K is my next biggest angle, so it makes sense that side K would be in between M and 8, so in between the 5 and the 8, and it makes sense that our hypotenuse is going to be the biggest side length. So there's the example. You should pause the video right now and try the your turn on your own. And since you're not going to actually do that, I'm just going to jump in and do the example right now, because I know that you're not going to actually pause it and try it yourself, because why would you, right? If I could do it for you. So here's P, Q, and N. That's what I'm trying to find. So side P is the hypotenuse, side Q is across from the 65, and then angle N is what I'm trying to figure out. So I'm going to do 90 minus 65 in order to get angle N, and that's going to be 25 degrees. And now to find P, what I'm going to use is cosine of 65 degrees will equal 10 over P, okay, because P is the hypotenuse. And when I go to solve this, there's two ways of thinking about it. One is that you can just flip-flop the P and the cosine, and that will give you a P equals. The more mathematical way is that we're multiplying by P to the other side, and then we're dividing by cosine 65 to move it. And when we do that in our fancy-dancy calculator, we should get 23.66-ish. 23.66. All right. To find Q, I'm going to use tangent. So I'm going to say tangent of 65 equals Q over 10, and I'll just multiply the 10 to the other side, and I will be done. And just put it in the calculator, and what do we get? 21.45. And again, we should just do a quick check just to make sure, does this make sense? You know, angle N is the smallest angle, so being across from 10 makes sense. That's the smallest side. 65 is a little bit of a bigger angle, so it goes to 21, and then our biggest side P, goes to our biggest angle, which is 90. All right, next we have 45, 45, 90 right triangles, all right? And they follow this pattern, x, x, x rad 2. So the two legs are equal because it's an isosceles triangle, and then the hypotenuse is always going to be x rad 2. And there's a bunch of ways that we can set this up. You can use a triangle. Some people find it really helpful to kind of make a little chart like this to answer every single question. I'm a little hesitant to make that chart just because it's annoying for me to write every time, and personally I recognize the pattern. So here, I'll do both ways for you. So for example, in 3a, I would say, oh, I have that side length of 8. I automatically know that this is 8, and so the hypotenuse is going to be 8 rad 2. Done. If I was doing B, I know that the pattern is that I'm multiplying by rad 2 when I move from a leg to a hypotenuse. So I would be doing 3 rad 2 times rad 2. That's going to give me 3 times 2, and it's going to give me 6. So I know that the hypotenuse is 6. Now, if that was rocket science to you, then what you should do is use this little table that I have going here. Okay, so we have x, x, x rad 2, and what we want to do is line up what we have. So we have one of the 45s is 8, and then we can line this up and say, hey, x equals 8 in this little scenario. So x equals 8, which means that this will equal 8, and then x rad 2 will be 8 rad 2. So I can literally just like solve for what x is, and then I can just plug it into the formula, and it'll just work perfectly fine. That's exactly what I did in B. I would plug it in, and I would say that x is going to be a 3 rad 2, and then I did 3 rad 2 times rad 2 for that pattern. If you want to look at the answer key for that one, you can see the work shown out. For this one, there's a couple different ways we could do this. So I know the pattern is that this is going to be 5, because the pattern is that the legs are, if they're whole numbers, then the hypotenuse is going to be 5 rad 2. It's going to be the leg times rad 2. If we struggle with this, that's fine. What we can do is line ourselves up inside of the table. So we have x, x, x rad 2. And what we were given was a 5 rad 2. So we know that these have to equal each other. And if I use the one-to-one property, I can see that x is going to have to equal 5. So I know that both legs are going to be 5 because they're both equal to x. All right, so your turn. So you should pause the video and try it yourself and see if you can figure this out. Since you're not going to pause the video, I'm going to just come in and show us what's going on. So here we have 2 rad 2. That's going to be our pattern, is that our legs were both 2, because we go leg, leg, leg rad 2. If you struggle with that, I suggest that you make the table and line everything up. You'll see that the x value in the table would equal 2, and that would work out perfectly. Over here, similarly, I know that it's leg times the square root of 2, so I would be doing the square root of 2 times the square root of 2. Both legs are square root of 2. That's going to give me 2. I'll make the table for this one just because it's a little bit more work here. So we'll have x, x, x rad 2, and what we were given was that the x values are rad 2. So I'm going to start off by saying I know x equals rad 2. So when I come over here and I want to do x rad 2, well, x is a rad 2. So I'm going to do rad 2 times rad 2, and that's going to give me 2. So I get that the y value is 2 for your turn, numero 50. All right, 30, 60, 90s are another one that you're supposed to know. These ones follow a pattern that the side across from 30 is x, the hypotenuse is always twice as big as that, and the side across from 60 is always going to be x rad 3. So if I make my fun little table, if it will let me draw the O's that it's struggling with, I would get that as my base table. All right. So if you're good at the patterns, you can just look at the triangle and say, okay, I know that the side across from 30 is 9. This is going to be 9 rad 3, if that had let me draw the rad, and that this is 18. So if you can see that, great. That just means that you can solve these really fast. If you cannot see that, that's fine. We'll make the table. Whew, my computer is struggling right now. I don't know why it hates me so much. Probably just overtaxing it with all this math, just like I am to you right now. All right, I get x equals 9 when I set up this little equation. So then when I jump in here, if x is 9, then this one's going to be 9 rad 3, and if x is 9, then 2 times 9 is going to be 18. Okay, so I know that the x value is going to be 9 rad 3 in the problem, not the x value in my table, and my y value is going to be 18. So that's super important that down here when I highlighted and said x equals 9, I'm talking about the table x, not the x that's in this problem. If you want to use a different letter, you can, like we could use S, S rad 3, and 2s. I don't like s's because they look like 5s. All right, this one is much trickier to do, kind of like more in your head. So as a math teacher, I know that this is going to be 3 rad 3 and that this one's going to be 6 rad 3. But I've been doing these for like 9 million years because I'm like, you know, ancient at this point. At least that's what it feels like. And might be easier for us to set up our pattern here with what we have. So the 9 is across from the x rad 3. It's across from the 60. So what we can do is set up a mini equation. X rad 3 equals 9. And then I can divide by rad 3, okay, to get what x is going to equal. But I, of course, have to rationalize, so I'm going to multiply by the square root of 3 over 3. I'm going to get 9 rad 3 over 3, which reduces to 3 rad 3. So now I know that the x value in this is 3 rad 3, and for the 90, I'm just going to do 2 times that. That's going to give me 6 rad 3. So for the x value in the actual problem, I'm going to have x equals 3 rad 3, and the y value is going to equal 6 rad 3. Okay, so we can just set up the table to help us out if we need to. All right, it's your turn. That means that you should pause the video and try it yourself. I know, so much fun. All right, if you didn't pause the video, then you're listening to me right now. So we're going to set up the whole pattern again. It's getting annoying to keep writing. I'm given the side across from 30, so that means I know what the x value is in my table. So I know that this is going to be x rad 3 is going to be the square root of 3 times the square root of 3. That's going to give me just 3. And this is going to be 2 rad 3. So once you find the x value of the table, then it's easy to figure out all of these things. They're specifically asking me for the problem, what is the side across from 60? So that's going to be 3. This one is a 30, 60, 90, and you might not have actually recognized that at first glance. Because these sides here are all 4, 4, and this is also 4, this is an equilateral triangle. An equilateral triangle have angles of 60 degrees, and when we drop an altitude in an equilateral triangle, it splits that top angle in half. So then we have a 30, 60, 90 on one half of this thing, right? So like this right here with a 2 and a 4, and there's our h, and this is our 30, 60, 90. So we were actually given 2 bits of information for this one. We were given that the 30 is 2 and that the 90 is 4. Either one we can use, we'll figure out that the x in the problem is, or in the table, is 2. So this is going to be 2 rad 3. So the height of this triangle is going to be 2 rad 3. And there is your turn for 30, 60, 90s. Ooh, arc length. Oh my god, doesn't that sound like so much fun? arc length is the actual length of an arc, so a curve around the edge of a circle. So like how far along the circumference it is to go from A to B. So not the full circumference all the way around, but just like part of the circumference. So you can see here, read all the words. I'm not going to do all of that. The thing that I think is most important about this is this part right here. We're being asked to find a percent of the circle. And the way that we can do percents is by doing, if it would let me write actual words, is by doing part over whole, that's a percent, times the circumference, okay? And we know that the circumference of a circle is 2 pi r. So what that means for us in our part over whole is we're going to use angles to figure that out, okay? So we're going to say if this is an angle theta in here, if we're in radians, we can do theta radians over 2 pi radians. So part of the circle, theta, part of the circle over the full circle, 2 pi radians. And in this case, it actually simplifies a lot. And the radians cancels and the 2 pi cancels. So if you're in radian mode, the arc length actually just equals theta times r. And there are some teachers who would ask you to memorize this and use this. I personally think that it's significantly easier to memorize that you're doing part of the circle times the circumference, and that you're doing theta over 2 pi, or if we look at the next one over, theta over 360. So I'm doing part of the full circle times the circumference, 2 pi r. This one technically reduces as well. It would reduce to like theta pi r over 180. It's not nearly as nice. And again, I personally wouldn't do either of these reductions. I would do that this is a percent of the circumference and that this is a percent of the circumference. And that's how I personally memorize these ones. Okay, so just a percent of the circumference. So doing example 8a, we have the length of AB, so I'm going to just abbreviate, not using proper geometry terms at all, but the length of AB is going to be 60 out of 360, so I'm using the angle that creates AB's arc, times the circumference, so times 2 pi 8. And then I just put this in my calculator, everything but pi, so I'm going to do 60 divided by 360 times 2 times 8. It's going to give me a decimal. I'm going to convert it back into a fraction, and then I'll add my pi value back in, and don't forget my units, because they're talking about an actual distance here. So I would get 8 pi over 3 centimeters. For this one, what they did is they gave me the arc length. They said the arc RS is equal to 44, and they're asking me what is the actual angle inside. So for this one, we would set it up saying 44, our arc length, equals theta over 360 times 2 pi, and then my radius, which is 15.28. So in order to get theta by itself, I'm going to multiply the 360 to the other side, and I'm going to divide by the 2 pi 15.28. And when I plug that into my fancy dancy calculator, I got 164.99 degrees, give or take. So that is going to be the measure of the arc RS. Okay, so the central angle is what we're looking for there. All right. It's your turn, so you should pause the video and try it yourself. But since you're not going to, I will just continue on doing what I'm doing. So if we're doing the length of GH, it really doesn't like when I try to do curves sometimes. GH is going to equal the part of the circle, 120 over 360, times the circumference, 2 pi 11. And again, we just type it in our calculator, 120 divided by 360 times 2 times 11, and then turn it back into a fraction, and that's going to give me 22 pi over 3, and we're in centimeters again. All right, so don't forget the units, that's important. 9b is asking you to find the circumference, and they gave us the arc length of xy, and they gave us the central angle. So what we have is 4.19 is going to equal 40 over 360, so the part times the circumference, so times 2 pi r. But this is the circumference. So realistically, what I really have is 4.19 equals 40 over 360 times c, the circumference that I'm trying to find. And I just need to multiply 360 and divide by 40 to move everything to the other side, and I'll get that c equals 37.71 inches. And I don't think that was that bad. All right, I think this is the last one for today, but I can't remember, you know. It's almost my bedtime at this point. Don't judge. But we have sectors, which are basically a piece of pizza. Okay, so it's the full piece of the pie. All right, so it's everything that's shaded over here, going from here to here, all the way around. It's all this junk. And what we have going on here is the same exact idea as before. I'll let you read all of the words of where this all comes from, but it's essentially a percentage of the area. So we can again do part over whole times the area of a circle, pi r squared. This would be our percent, again, the theta over 2 pi if we're in radians, or theta over 360 if we're in degrees, times the area. And the radian one simplifies again because the pi's can cancel, but it doesn't simplify much. We would get theta r squared over 2. So again, not something I would personally choose to memorize. I'm going to memorize it like this, that the part over whole times the area is going to give me the part of the circle's area that I'm looking for. Okay, so I'm doing a percent of the area. So when I get down here, it's asking me to find the area of the sector formed by the angle UTV. Remember, when there's 3 letters, that the center one is where the vertex of the angle is. So this is angle T. And since it went from V, T, V, they're talking about the actual 70, not the greater one that goes on the other side. So I'm going to say the area equals the part 70 over 360 times the area of this circle. So times pi 8 squared. And again, just like before, we're going to not type the pi in our calculator, and we'll just do 70 over 360 times 64. And we will get that the area is 112 pi over 9 units squared, because it's area. So remember, our units are squared. For 10b, they're asking us for the area of the entire circle, and they gave us the area of this little sector. So we have that 35 equals 40 out of 360 times pi r squared. And just like that circumference one that we were just doing in the last year turn, this is the area. So all I need to do to get the area by itself is multiply by 360 and divide by 40, and I'll get that the area of this thing is going to be 315 meters squared, so the full area. Now, another way that you could do this one is to think about it a little bit more logically. If you said I have 360 degrees total, if I divide that into 40 pieces, that's going to give me something like 9. So there's 9 pieces that would make 40 degrees. And if each one of those is 35, we could do 9 times 35. It's not 9, is it? Did I do my math wrong now? Math is so tricky. 9 times 35. I was thinking 9 times 45, and I was like, that definitely is not 315. My bad. Can't do math in my head. 9 times 35, that should probably equal 315. So there's other ways that you could solve this as well. We're on to the your turn. You should pause the video and you should try it yourself, which I'm sure you're going to do. And if you didn't, then hey, how's it going? Welcome to the your turn. We're going to do the area equals the part over 360 times the area of the full circle, so times pi r squared. Plug it all into my fancy dancy calculator, and I get 196 pi over 3 feet squared. And there's my area of the sector EDF, which is the kind of pink one if you're not colorblind. It's the one that has the 120 in it. For the area of the entire circle, I will again start off just like we kind of did in the practice one, saying that the area is going to equal the part over whole of the area of this entire thing. So what I really need to do is just solve for this. And I can do that by multiplying by 360 and dividing by 85, and I'll get that the area of the entire circle is going to be 907.92 centimeters. For these ones, we can type in pi. We don't need to leave our answers exact, and that's because we already have a decimal that we're working with. It's already been rounded, the 214.37. All right, hopefully this made sense to you, and hopefully it was mostly review. There's just optional extra practice with solving. Here's completing the table. So you have A, B's, and C's. The A's are 45s, the B's are 45s, the C's are 90 in this one. Down here you have D is a 30, E is a 60, and F is a 90. So you can kind of fill in the rest of the pattern based on what angles they are using the ratios. Here, just more practice, 30, 60, 90, practice, 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 practice. Here's some arc length, and area sectors, and then some word problems with them that aren't super crazy difficult for you. And that's your optional practice. Fair game, all of this could be on a test or a quiz, so you're expected to know it, even though that this is an optional practice and you don't actually have to do homework on it. So you're expected to know everything in this day's section, and any of it can and will be on your unit test. All right, and I will leave you there, and I hope you have a happy rest of your day. Don't forget to like and subscribe, and I'll catch you in the next one. Bye!